Hi guys, welcome to lesson 1B, and today we're going to put into use from our last little lesson the labeling of right triangles for trigonometry. Let's first look at our little warm-up, and with our warm-up here, this is basically just a little review of using Pythagorean theorem to find the missing side length and reminding ourselves that our right angle, kind of the notation, points to C. That's always going to be C, and it doesn't matter if this is A and this is B or the other way around. I'm going to take my 13 squared plus my x squared equals 14 squared. And then I will solve for x following the algebra. 13 squared is 169 plus x squared. And then our 14 squared is 196. 196 minus 169 is 27. Take the square root of both sides, and x equals 27 units exactly. Remember, exact form. I could toggle my calculator, and well, this also reduces to 3, square root of 3. And toggle my calculator, and I get 5.196. So if I'm going to round to the nearest tenths place, I would say approximately 5.2 units. This time I'm looking for C. So I'm going to take my square root of 82 yards. And I'm going to square it, plus my 9 yards and square it. It's going to equal my x squared. 82, the square root of 82 squared is the square root of 82 times the square root of 82. This is going to cancel each other out. Remember, square and a square root are opposite operations. $163. It's equal to my x squared. Take the square root of both sides. And I get the square root of 163 equals x. So x, I could say, is exactly root 163 yards. Okay, let's get into right triangle trig. You can use trigonometry to find unknown sides and unknown angles in a triangle. You just need two pieces of information. So we want to study how the sides and the angles are related to each other. This right here that they're showing you, I would be looking at, this angle would be my theta, or my angle of interest. It's how I would label my triangle. Remember, opposite, hypotenuse, adjacent from our last little lesson. Okay, these are the three trigonometric functions we're going to use in our right triangle trig. Sine, okay, and it's abbreviated SIN. Cosine, co of sine. So these are kind of co-workers, and it is abbreviated COS. And then tangent, and it's abbreviated TAN. Okay, so to remember all those ratios, what we're going to look at is a little mnemonic device. We got some old hippie came a hopping through our apartment. SOH, CAH, TOH. So here we know that our sine ratio is our opposite over our hypotenuse. Remember, ratio is like a fraction. We also see it written like this. Our cosine ratio is our adjacent side, that's supposed to be J, over our hypotenuse. That's the C, the A, the H. This S is sine over opposite and hypotenuse. Sine equals opposite over hypotenuse. And then our tangent ratio is our opposite over our adjacent. So tangents opposite over adjacent. We also see this as SOHCAHTOA. It's another way to remember it. This is our Greek letter for theta, and it represents our unknown angle or our angle of interest. So when we're looking at this triangle, sine is just our opposite over our hypotenuse. Cosine is our adjacent. I know A for adjacent, C for cosine, over our hypotenuse. We're talking about trig ratios. Tangent is our opposite over our adjacent. Okay, they can be used, again, that's SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and TOA, tangent is opposite over adjacent. Okay, so I've got my angle of interest here. Sine is going to be the opposite leg over the hypotenuse. Cosine is my adjacent leg over the hypotenuse. And tangent is going to be the opposite leg over the adjacent leg. So this, if I label, here's my hypotenuse. This is opposite of my angle of interest. If I arc it, notice that the arc touches the hypotenuse and the arc touches the adjacent side. If I change my angle of interest, this is the same triangle. Now here is my angle of interest. My hypotenuse has not changed places, but now the arc touches this side. So this will become your opposite, and this is your adjacent. Here are your trigonometric ratios with their definitions, the symbols we've already talked about, and a diagram. You're welcome to freeze the slide and take notes. And let's take a look at some of these things. So we're just going to set up our trigonometric ratios. So I'm going to do tangent of A. So A is my angle of interest. Tan, remember, is opposite over adjacent. So I'm just going to label opposite and adjacent for this angle of interest. This one is my opposite. This is my adjacent. So tan of A, the ratio is 8 over 6. Same thing as 4/3. Here's sine of C. There's my angle of interest that I am going to arc. Remember, sine is opposite over hypotenuse, so that's all I'm going to label. There's my hypotenuse. This has to be adjacent because that's touching the arc, so this is my opposite. So my sine C ratio is going to be 35 over 37, and I don't think that reduces. Cosine Z, first thing I will do is arc angle Z. Cosine is adjacent over hypotenuse, so that's what I'm going to label. There's my hypotenuse across from my right angle. It's pointing at it. The arc is also touching my adjacent, so my cosine Z is going to be my adjacent of 16 over my hypotenuse 20. I can simplify that to 4/5. Tangent of X, remember, tangent is opposite over adjacent, so I'm going to label those sides. I've got, this is my hypotenuse, so this one has to be my adjacent. There's my opposite. So I'm going to have 12 over 35. Now, it's asking me sine A, cosine A, tangent of A. Which one is which over here? Sine of A, tangent of A, cosine of A, and tangent of A. So A is my angle of interest. I'm going to go ahead and label this triangle. Here's my opposite, my hypotenuse, and my adjacent. Sine of A, remember, is opposite over hypotenuse. So my opposite is 5, and my hypotenuse is 13. So this one would be E, right here. cosine of A, that's adjacent over hypotenuse. Cosine of A is 12 over 13, so that's this one right here, or L. And tangent of A is opposite over adjacent, so that'd be 5 over 12, which happens to be this one. I'm going to take a gainer that this is an O, that this spells love. I don't see an option for white, so I'm going to put myself an O there. That's how we handle these problems. Let's do a few more together. Okay, this is all sine of B, cosine of B, tangent of B. So B is my angle of interest. I'm going to label the triangle off my angle of interest. There's my hypotenuse. That has to be the adjacent. Here's my opposite. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Just basing it off of my SOHCAHTOA. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. Okay, so opposite over hypotenuse, 12 over 13. That's this one, making this a W. Adjacent over hypotenuse, that's 5 over 13. So this one's a Y. And then opposite over adjacent, that's 12 over 5. Now we're doing again A. So I'm going to label opposite, hypotenuse, adjacent. I'm going to cut down some of the work now. Sine is opposite, which is 1 over hypotenuse, which is 2. We're going to label this one an A. We'll spell weight. So this one's going to be A, 1/2. Cosine is adjacent over hypotenuse, square root of 3 over 2. And tangent's opposite of 1 over adjacent, square root of 3. Label from angle B, hypotenuse, adjacent, opposite. I'm going to go ahead and give this a letter of S, we'll say, just because. Sine is opposite over hypotenuse, square root of 3 over 2. Cosine is adjacent over hypotenuse, which is 1/2. And tangent is opposite over adjacent, square root of 3 over 1, which is just the square root of 3. This is all again off of A, and I'm going to label hypotenuse, adjacent, opposite. So sine is opposite over hypotenuse, 12 over 15. And that reduces 4/5, so that's U. And then I've got cosine, which is adjacent over hypotenuse, which would be 9 over 15, which is 3/5. And then finally I've got opposite over adjacent, 12 over 9. And we do want to reduce this to 4/3. We'll label this T. Got time for just a few more. So then we're going to label this as all off of B as my angle of interest. There's my hypotenuse, opposite, adjacent. Sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. And then opposite over adjacent. I think this will be our last example. I think there's one more in your little packet, but you should be able to follow that one on your own. So I'm going to label hypotenuse, opposite, adjacent. Sine is opposite over hypotenuse, and you would have to reduce it. Cosine's adjacent over hypotenuse, and you reduce it, and then opposite over adjacent. Okay, guys, see you in the next lesson. Bye.